Math, calculus.
Okay.
Alexis's birthday today. Happy birthday, Alexis.
2020.
Okay, thanks for that again. Okay, so as we stated before, well, hopefully as we remember from the last lesson, the main reason that we differentiate an expression is to be able to find the gradient of a function. Okay? Now, hopefully we remember that gradient is the rate of change that y changes with respect to x. So change in y over change in x. And this, having the derivative enables us to find that gradient at any different value for x. So remember that very first function, the gradient was different at different parts of the graph. This enables us to find that gradient at those different places. So once you've got the derivative, you may be asked to calculate the numerical value of the gradient. So we did do some of these questions last lesson, but we'll just go through this example just to make sure that we're comfortable with it. So once you've got the derivative, you then just substitute the value of x that you need to into the expression. So here's our function. Fx is equal to 2x cubed minus 2x plus 4 over x squared. Quite a lot for the benefit of Natanya. What should we do first with our function? Nice. Good call, Emma. Okay, so we're going to get the fraction out of the way. The reason being that, Natanya, when an x is on the bottom in the denominator of a fraction, we cannot differentiate it. Okay, we need to have it in line with everything else. So I'm just going to first of all rewrite my expression. So the first term is fine, so I just copy that. My second term is okay. How do I rewrite the 4 over x squared? Nice. Plus 4x to the negative 2. Good. Okay, so we've just rewritten our function. Now we are able to differentiate it. So we show that by doing f dash x. Okay, Jodie, do you think you're comfortable doing this for me? 6x. Yep. Minus. When there's just an x next to it, you just drop the x.
Minus 2. Plus 1 minus 8x. No, negative. Negative 1.
Careful.
Negative 3.
Okay. So, Natanya, the rule is the power goes in the front, so you multiply by whatever the power was, and then you subtract 1 from the power. Okay. So that's where we get these 3 times 2x squared. When there's an x, the x just drops off, and this one obviously becomes negative 3 because you've taken 1 of it. Now, you will always have your calculators available to you, but just as a reminder, because sometimes fanning around with your calculator is just a bit annoying, if we rewrote this back to the fraction format, we would have 6x squared minus 2 minus, how would I change that back? Nice. Okay, all happy with that? So now we need to find the gradient at the point 213. Now, sometimes they will give you the full coordinate, which they have in this example. Sometimes they will just say when x is a given value. We do not care what this value is. That's neither here nor there. We are only interested in the x value because our expression, our derivative, only has the letter x in it. And what does the 13 represent? Y. Okay? So the 13 is not important. So if it's there, great. If it's not, don't worry about it. So we're now going to substitute the value 2 in. So we've got, so we're finding f dash 2. Okay? So remember that in function format, that's how we will show it. So that's 6 lots of 2 squared minus 2 minus 8 over 2 cubed. Okay, let's practice our mental arithmetic. What do we have to do first with the 2 squared? The 2 squared, so 2 squared is 4 multiplied by 6 And what's 2 cubed?
8.
So it's 8 over 8. So that's 24, subtract 2, subtract 1, which is 21. What's the answer? Okay, so at the point 213, where it was, on this particular function, the gradient would be very, very steep. It's going to be 21. Okay, so it's a positive, very steep gradient. Okay.
But it doesn't matter what you do first if we do 2 squared and then 10 times 6 or 6 times 3 times.
Yes, very different.
Which one's good?
We have, so
Which squared?
we always, in any mathematical calculation, we will always follow order of operations, or set math or math, whatever you want to call it. Yeah? And that means that we must do, well, I put the 2 in a bracket, it doesn't have to be, but it means we do the exponent first, because that's that second letter, or whatever you call it. Yeah? So, and that's a very common error that people make. Because you have your calculators available to you, you could just shove it all in at the same time, and your calculator always follows the order of operations, so you shouldn't worry about it, but just be careful. Okay, so a few more, let's go the way. So find the gradient of the curve, y is equal to blah blah at the point, is that 1, 9? 1, 9. Any suggestions what we would do here? We've got 3x in front of our bracket. Expand out, perfect. Okay, so always look at your function and say, can I differentiate this as it is? We haven't talked about anything being multiplied by something else, so we need to expand that out first. So first step is to expand that. Layla, do you want to expand that for me, please?
21x subtract 12x cubed.
Nice. Okay. Amelia, would you like to differentiate it for me, please?
Y dy over dx equals 21. Subtract 36 x squared.
Beautiful. Samantha, what do I do now?
You substitute the 1.
Okay. X equals 1.
21 is 30.
Mundo, nicely 1 squared is obviously 1. So 21 subtract 36.
Wait, where did the difference?
We got this, Emma, from up here. Is that what you're asking me? Sorry, pardon, what was the answer? So on that function, on that curve, if we were to sketch it at the point where x is 1, we would see that the graph was negative, has a negative gradient, and it's pretty steep. Okay.
Why did you do y over dx instead of the y dash?
I think we had this discussion yesterday.
I know, I
So that when it's fx, you write f dash. When it's y, you write dy dx. It's just two different. It's like you're called Emma, she's called Emma. Okay, it's just a different way of saying it. Okay, if y is equal to blah blah, find dy dx when x is equal to negative 3. Jersey, do you want to hook me up? The enthusiasm is outstanding.
y equals,
What's equal to dy dx?
okay, 11.
You sure? Oh, yes. So Natanya, this is one for you. So when there's just a number, no x at all, you completely ignore it. Okay?
So negative 8x cubed. 3x. Oh, 9x.
Beautiful. Love it. Okay. Oh, you're going ahead. Keep going. Okay. So no, you totally can. So when x is negative 3, we're now going to substitute that value in. So we've got negative 8 solve. Okay, so negative 3 cubed would be what? Negative 27. So we've got negative 8 multiplied by negative 27. And negative 3 squared is positive 9, yeah? I don't know what any of these numbers are. 160, 260 minus 81. I don't even know what that is. Can someone check and make out?
Oh my lord, I did on my phone. Okay, minus 27. It's 216.
No, I said that. I knew it was 260. I did like 81, but I just kept talking about that bit.
So 216 minus 81?
Yeah.
That is 135.
Thanks.
So 216, right?
Yeah.
Minus 81.
Yeah. I did say out loud, maybe not loud enough, because it's 16 minus 81, but I just couldn't remember to do that bit in my head.
I hate subtraction, it's so annoying.
What? Alright.
You're insane.
Okay, so, next one. Now, this one here looks a bit different, because we've got A's and we've got R's. Okay?
Oh, no.
The process is exactly the same. When the expression up here was a y equals, okay, and it was x is in the expression, we wrote dy dx, yes? Here we have an a at the front, and this expression is to do with r's. So we write dA dr. That's the only difference is, again, what it's called, okay? So this one is A and R, so we write dA dr. So we want to find the value of dA dr, or in other words, the rate that A is changing with respect to R, and specifically the value when R is 4. So we look at our function. Do we need to do anything with it? Hannah,
Yes.
sorry, do you have a question?
Can it be any letter?
It can be totally any less. Yeah.
But not DAVR.
No, well, I think Hannah means if this is different letters, this will be the same letters. Yeah. So this is always connected to this, but these can have any letters.
But if those were like...
So this could be S equals 5G. Okay. You could have then DS DG.
What is it?
It's just. Don't worry about it. Sorry, that's a really rubbish answer as a teacher, I should say. Go into it, but really.
I could just meant like this.
Okay. Do I have to do anything with this first?
Yeah, fraction.
Deal with the fraction. So I'm going to rewrite A. So A is equal to 5R plus. Good. So then I would find dAdr. So that would be 5. I'm just going to do it. I'm quite confident that you're good with it. Minus 16R to the negative 3.
Is it 5 plus 3? Oh, never mind.
No, why have I gotten minus?
I know.
Yeah, because the negative 2 here. I'm going to rewrite that so to make it a little bit easier when I substitute my value in. But again, you're in your calculator, so it doesn't matter. Okay? And so when x is equal to, not x, maybe, and r is equal to 4, it's 5 minus 16 and 4 cubed.
Why do you put it back into the fraction?
Well, because I don't know what 4 to the power negative 3 is. But when it says a fraction, I can deal with it as a fraction.
You're really calculating.
Yeah, that's why, and I keep saying that. Like, I just don't have my calculator. And 1664. So that's 5. I'm really taking up a lot of space. But let's just tell me what that one is. It's no rush. 5.1. So it's 4 and 3/4, yeah?
What is it? So it's 5 minus 16 over 64?
Yeah. I mean, yeah, and Pete, you essentially in your exam, you just need to do this, and then substitute it in, and you get this, okay? Do not worry about rewriting all this stuff.
You have 4.7.
Yeah. This is partly as a review for you as well, because this comes into play with other kinds of questions. And our last one, what do we had one like these the other day. Does anyone remember what we did with it? Separated, yeah. So I've got y is equal to x squared over x squared minus 4 over x squared.
So is that y thing, that question right there? Oh, it is.
Are you talking about the one with just there?
Yeah, no. It's another question.
Do you know how to find it? I don't win any prizes for observation. Okay, so x squared over x squared is obviously 1, and then the minus 4 over x squared would be minus 4x negative 2. So I've rewritten my expression so I'm able to now differentiate it. Please don't forget, do not start differentiating it until you've established whether it needs rewriting. How did I what?
The y minus 4.
1 minus 4x is x squared over x squared.
Because that's 1. And then... Okay.
You are funny because sometimes you ask questions and I...
Is that a big safe?
Yeah, totally. Alright, so dy dx. I don't know if you're doing it to test me sometimes.
No.
You genuinely are asking. Alright, when it's a constant number, it just out the window. So we've got negative 2 multiplied by negative 4. So that's positive 8x and negative 3. And yes, I am going to be writing it. So when x is 4, that's going to be 8 over 4 cubed. 8 over 4, 1. Okay, just yes?
Can you also write it in the decimal form or no?
You can, yeah.
Is it going to
No, if it's a recurring decimal though, so if you get 1/3, leave it as a fraction. Just because you may lose your recurring sign and it's not good. Oh, we've got more?
Yeah.
We have a lot more? Wowzers.
Should we do practice then?
Well, these are practice. I tell you what, why don't I let you do this, try this next page without me, and we'll come back and just check everyone's good with it.
Questions? Yeah.
Yeah, there's still examples, okay, but they're all related to those things. So I'll pause it for a little bit. You can... All right, okay, so as I said, gradient function in this question means the same as find the derivative, so just recognize that that's what that means. Latanya, let's see if you've been paying attention today. So dy dx, I'll give you a clue, that's what we're finding.
Okay. 3x.
Secretly not yet, no. Where'd you get 3?
2x. I look like a 3.
Okay, you put it in front of you as well, darling.
Oh, yeah.
2x.
That's it.
Plus plus 3, yeah. So this has got a secret power of 1, which obviously we didn't write. And when it's just an x here, you just drop the x. And the 4, the negative 4, just leaves it alone completely. Okay. The tip I gave these guys the other day was that if you had forgotten and you'd written minus 4, then you would have been able to simplify this. Okay. If you're able to simplify a derivative, you've done it wrong. Okay, because nothing in this original one can be simplified, therefore nothing in your derivative can be simplified. Okay, right, so there's our derivative. That's part A done. Check. Now, the other information they gave us was that the gradient of the curve at the point P is equal to 7. So what does that mean? It means that what tells us about the gradient? This expression, yes? So this expression here tells us about the gradient. They've told us what the gradient is or what it's equal to. So what do you think we might do?
Substitute it in.
How do we substitute it in? Be careful. It says that the gradient is equal to 7. Hannah?
Equals.
I'm going to write 7 equals 2x plus 3.
Oh, and then you
Yes? Does that make sense? So this is our gradient function. They've told us our gradient is equal to 7. So our gradient function that we've just worked out, we put equal to 7. And it also seems sensible because they've asked us to find the x coordinate. What's our automatic reaction to do when we see something that says 7 equals 2x plus 3? Yeah, we're going to solve it and find the value of x. Yes? So finding x is going to be solving. So we're going to take 3 from both sides. It's really not 16, Emma. So x is 2. Okay, so our value of x is 2. Cut C says find the y coordinate. How do we do that?
Well, x is 2. So then you substitute it in. Would you substitute 2 into the
Into the original
and
function.
then
Pardon, Jodie?
Into the original function.
Good. Into the original function. Why is it the...
oh, because we solved
Ashley, why is it the original function?
Into the original function.
It's awkward that we weren't paying attention to it. Okay, always helps when we're going through an example to make sure you're listening, sweetheart. So we've established the value of x is 2. We've been asked to find the y coordinate. Jodie said that we need to, Jodie said we need, Emma, someone said that we need to substitute this value in. And Jodie has said that it has to be this expression here. Why does it have to be this one? But why? W-H-Y.
Trying to find the...
What is this? What is
Trying to
this?
find the y coordinate.
Yes, and this is a rule to find y. Yes? That's what y equals. That's what y equals. All right, so y is equal to 2 squared 3 lots of 2 minus 4 minus 4.
4 plus 6 minus 4.
Okay,
Wait, does it matter which one you do? Like, can you do 4 plus 6 minus 4 or 4
Totes.
minus 6?
yeah.
Good.
Okay. Should we just carry on with this then?
Yeah.
All right. Here they told us how many points are there.
2.
Now, what can we see? What have they done here to help us? They've bolded it. Now, I don't mean to be rude, but some of you, not so much reading stuff like that. Okay? When they bold stuff, it means, ooh, whoop, whoop, look out for it. Okay? And it's not just your normal question. All right? So there are 2 points on the curve where the gradient is 6. We need to find them. So what are we going to do first? Find the derivative. Good, because the question has told us about the gradient of the curve. So as soon as we see that, we know we need to be finding dy dx. Okay, so Aria, what's my derivative, please?
3x times 2 plus 3.
Lesbians, okay? And Emily, what do I do now? To where? Tell me what to write. Oh, careful. What does this tell us? Why did we do that? Pardon? And what does the derivative tell us about? The gradient, okay? And what have they then told us? That the gradient is 6. Good, we're going to put that equals 6. Good. You're telling me good, Karen? Thanks, Emma. All right, okay. Now, kind of annoyed that this isn't a different kind of expression. But anyway, what do I see here? I see an x squared. How do we often solve things with an x squared? What's our normal? Yes, we're going to take the square root at some point, but what's our normal thing when we have an expression with a squared? What do we normally put it equal to? Oh, well. If I had x squared plus 7x equals 5, and I wanted to solve that, normally I would rearrange it to equal 0. And I would then use my quadratic formula, or I would factorize it. Okay? So that's oh my gosh, go. So this is a recap as to those kinds of things. These come in quite a lot. So this one is not in this vein because there is no x term. But I just wanted to remind you because quite often they are. Now this one we don't need to do that because we've just got the x squared. So we can take away 3 from both sides. So we've got 3 equals 3x squared. I can then divide both sides by 3 and I get 1 is equal to x squared. Now this is where the fact that they bolded that word at the beginning is important because we know that x squared is equal to 1. So now to find x we square root both sides, yes? What's the square root of 1? Be careful here. 1 or negative 1, okay? So remember at this level, we've got to remember that when we square root stuff, we've got both the positive and the negative version.
Wait, I don't know how I did it wrong to find x.
Okay.
I got the square root of 2. Because
Right.
I did, I subtracted, so 6 minus 3
Is
3.
good.
I wrote 6.
Right. There's our issue.
So then you do 3 divided by 3, right? Got it.
Awesome. Alright, are they my coordinates of the 2 points?
So we're not gonna solve to find y?
No, that's why I just asked that. Okay. You are right, Jodie, we do need to, because these are not my coordinates, are they? They're just the x part. So if it said find the x values, we're done. But this says find the coordinates, so we now need to find the y part. So let's call x is 1 or x is negative 1. I'm going to say this is x1, x2, okay? Because our y values have to be attached to the corresponding value of x. So our y1, we would stick 1 into the original function. So what?
So we got 2 answers.
Yes, because we've got 2 answers. So we've got 1 cubed plus, plus 3 lots of 1 plus 4. And then y2 would be negative 1 cubed. I'm in your way, aren't I, Jodie? What are you saying? Honestly, I think you got bonkers. Alright, 1 cubed is 1 plus 3 lots of 1 is 3. So 1 plus 3 is 4 plus another 4 is 8. Oh, shush now. And then our y2, negative 1 cubed is negative 1 plus 3 lots of negative 1 is negative 3. So we've got negative 1 and negative 3 is negative 4 plus 4, 0. So our 2 coordinates are 1 and x, negative 8.
Isn't 1 to the power
Oh, it's not negative 8. It's not negative 8.
Because it's really cool.
And negative 1, 0. Sorry, Emma, what did you say? What are you saying, sweetheart?
How did you get 8?
1 cubed is 1. Yeah. 3 times 1 is 3. So 1 plus 3 is 4. Plus 4 is... Yeah, we're good? Okay. So far, so good? Okay, so this is my final answer. They were my two coordinates that I needed. I ran out of the space. I didn't do that very well. Okay, next question. Point P, which has the coordinates 1b, lies on the curve y is equal to blah, blah. Find the value of b. Would anyone like to propose a way of finding b? Just put the 1 in. Nice. Why? Y is b. I love it. Okay, we all good with that? So part A, we're going to substitute 1 into the expression. I've stopped using colour. Oops, that's not what it is. Okay, so our y value is -2. Yes? Like that? No, 7 please. I'm hoping that means yes. So b is -2. Part B, Emma, says find the gradient function. Anyway, I don't think I've asked you anything today. So 2x minus 4, now C. Part C, show that at P, the gradient of the curve is also equal to B. Okay? So, C, how are we going to do that? At P. So what do we know about the point P? We know the coordinate is 1, 2, it's -2, yes? We know that the gradient function is 2x minus 4, and they've asked to show that at P, the gradient is also equal to B. So what do we need to do?
Put the coordinates into the
Yeah, which part of the coordinate do we need to substitute in, Jodie? Which part do we always substitute in? The X. Are you being quiet? You have lost your voice.
It's lost my voice.
Oh, bless you. So at P, X has a value of 1, and so the gradient is 2 lots of 1 take away 4, which is -2. Okay, and we've shown that that's the same value as B. Okay? Yes?
How did we get B?
How did we get B?
Yeah.
So, it says up here that the coordinate, the P, point P is 1, B. Yes? What does B represent?
Why?
Y. Yes? Funnily enough, we have a rule here that tells us what Y is. Yes? That involves a value of X, and we can see the value of X is 1. So what we had to do was substitute this value 1 into this expression.
No, I mean like question B.
Oh, I apologize. The gradient function. So we differentiated it, Danny. 2 goes in front, take 1 off the power.
Yeah.
Yes?
Yep.
Sorry,
Yeah.
that was a speedy one because that's the same as what we've been doing.
Wait, so
Okay, so part D, it says point Q is the point on the curve at which the gradient of the curve is equal to -2. Show that D is equal to -2. What? Well, our gradient has been -2. But it's the same thing, isn't it? That's a silly question. I'm sorry, we're teaching that. We're working online. So, if this has been a different... Okay, the reason I'm looking at it weird is that they've said that this point Q is when the gradient is equal to -2. Well, we've just had a gradient of -2. So it must be the same point. So point P and point Q are the same coordinate. We got it wrong. We didn't get it wrong. This is just ridiculous. Okay?
How we could do that one?
All right. Okay. So